I know we still have a few folks joining. You will notice one thing that's different on for this particular webinar is that we have a Q&A box instead of just a chat box. So as you move through, if you have any questions for our speakers, please put your questions into the Q&A box, and we have someone here monitoring that as we go forward. That's just some preliminary info. Kelly, would you next slide, please?
Very much so like to, Pat. There we go.
Thank you. So my name's Pat Tovey. I manage scientific and regulatory affairs for PFI. I want to thank everyone for attending this webinar. This is part number 4 in a 4-part series, and this one is focused on calorie and fiber calculations. Without a doubt, everyone, this will be the most information-dense lesson in the series, so may also take the longest. I know we've had in the past we've had good luck getting in under time. That may not be as true today, so we're moving right through it rather quickly. Next, Kelly. And as that comes up, our first order of business is to remind everyone that this webinar, just like all PFI calls, is governed by our antitrust policy. It states that we're here to discuss and learn about compliance issues with the new PFLM requirements, not to discuss favoring or disfavoring anyone in the marketplace. We're going to avoid conversations or questions on items such as pricing or market share or any type of business agreements. So if at any time you feel that we are getting into antitrust territory, please let me know or let one of our speakers know, and we will change the conversation. So I will ask if there's any questions about the antitrust policy, and I guess if there are, you can put those in the Q&A box. Let me know if anything comes up on that. But moving on on to the next slide. Our series of webinars is on the screen right now. If you look, today's is circled. Keep in mind that all of our webinars, these are open to anyone interested or wanting to learn about the label changes, but the intent of these specifically is to be tailored specifically for pet food manufacturers, pet food makers, both PFI member and non-member companies. It's important for us to understand our responsibilities for these new labeling requirements that have been printed by AAFCO. And with that in mind, AAFCO will continue to hold their pet food labeling workshop. I just want to be clear that a lot of our members volunteer for both planning and presenting AAFCO's labeling workshops, and we support those. And we strongly urge anyone here to attend those, as we think it works very well in conjunction with this training. Next slide, Kelly. And this is our list of trainers, and we have plenty for this one, so I'm going to move through them quickly. But I think that the thing from the outset to understand is that our speakers that we're bringing forward here are the folks who are responsible within their own companies to make these updates and these label changes. So first of all, Lauren Bennett, who is handling a lot of this for Nestle Purina. We have Leslie Hancock and Leah Lambrakis with us today. Both of them are chair and vice chair, respectively, of PFI's nutrition subcommittee. Carrie Nichols and Lars Ryman are both here and from Eurofin Scientific. So they're providing our industry with a lot of support and a lot of testing resources for many of the changes to our labels. James Templeman, who is managing the label updates for Primal. We have Angel Thompson with us, who has been involved in pet food label modernization, both with FDA and AAFCO since even before the inception of these coming out. And Ding Wong, Director of Nutrition for Bright Pet. I also, before we move on, want to thank Patrick Fulling for generously volunteering to monitor our question box for today's webinar. Next slide, Kelly. So what we're here for today is to talk through the nutrition facts box. We're going to, next slide. This is our agenda, and as an overview, kind of an overview of what we're going to go through today. And I think as we get started here, the first part that we're going to talk through is going to be an introduction and giving us some preliminary and needed pieces of information that we can build upon to understand the rest of the webinar through the calculations. And to do that, we'll start out. I will turn it over for the introduction over to Angel.
Great. Next slide then. Hi, I'm Angel. Thank you everybody for attending today. So go right ahead, next slide. So what the heck are we doing today? Last seminar, so it was held a month ago. Last seminar, we talked about the nutrition facts, and we talked about all of the words and the placements, and we talked about total printable area and all of those kind of details. This seminar, you see all those X's in what's in front of you in this slide. Today, we're going to talk about filling those X's. It's a little bit intimidating because it's quite a bit there. And the foundations, though, are the same. You'll find many similarities to just what we do today, but it's not the same old, same old. There are definitely new twists in what's required, what the numbers are, what they mean, and we're going to take you through some of those information. And then at the very end, we've got a really nice example that builds on this seminar, takes all of those pieces and puts it together into filling in the numbers in the slide you see before you. Next slide, please. So before I start filling in those X's, what do I need? Well, you need to determine your lowest whole familiar household unit, and we'll dive into that just after this slide. You'll also need to know the weight of that unit in grams, so not ounces, but grams. Maybe we finally come into the 21st century, grams. You also need some product analysis and/or some reliable predictive calculations based on a solid, scientifically determined ingredient nutrient database. You need to set guarantees, and that'll also be covered in a section in a bit. Again, minimums and maximums. We're not talking about typicals. We're talking about maximum or minimum guarantees. And you'll need your averages of your finished product analysis, approximate analysis, for crude protein, crude fat, crude fiber. So keep an ear out for fiber because we're going to get into that quite a bit. Ash and moisture. The other thing you need is to know, and again, we talked about this in the earlier session, which all of the previous sessions are available online. You need to know the total printable area of your label in order to determine which format you're going to use on your label. So we're going to jump into familiar household unit next. So next slide. This is the first line of the under the header, and it is telling you what the unit is. So you should look at the feeding directions, and these should be common household units. So do I have a dry measuring cup? Do I have a tablespoon? Or do I have a can? And the regulations require that you look for the lowest whole. So you might have feeding directions from half a cup to 5 cups, but we're really looking for the lowest whole cup or the lowest whole, say you have a baked biscuit, the lowest one piece. So if your feeding directions are by cups, use a whole cup, 1 whole cup. If you have feeding directions by biscuits, you feed a biscuit. Do not use a fraction. I don't have a fraction of a teaspoon that goes down to say 1/8. You might have some little tiny bit that's not a usual piece or not a usual measure. Look for the lowest whole common measure. But what if you have something like and if you look on the bottom, think of jerky. If you have a non-uniform product, so something that's not really manufactured from the standpoint of being put through a machine or a mold or measured out somehow like in a can or a pouch, what do I do if I have that? Well, in that case, you take a lot of weights in grams, remember, a lot of weights in grams, you average those of those pieces, you average that, and what you get is the very last bit on this slide, which is one piece, in this case, equals 15 grams, but you add the parentheses in order to indicate parentheses AVG. This is an average so that the consumer is aware that there will be some variation in the actual weights of the pieces, but that the average piece will weigh about 15 grams. So we're going to dive a little bit more into household unit, particularly of cup, and I'll turn it over to Ding Wang next. You're on mute.
Thanks, Angel. Next slide, please. As mentioned, household unit has many different forms. That's the tablespoons, teaspoons, that Angel just mentioned, like cups. You can choose whichever unit fits your need. But please know that this household units are volumetric measurement. Here I'm using cups as example. So the weight per cup equals the density of the product times the volume of the cup, so which is 8 ounces in this case. Therefore, the weight per cup actually varies with the density of different products. Product density can be influenced by many factors, including the type of the product, different formulas, and shapes of the products. For example, freeze-dried products are known for their light density. A freeze-dried morsel product with around 95% fresh meat, organs, and bones can weigh around 48 grams per cup. In contrast, extruded cable is much denser. A disc-shaped dark cable with around 25% protein, 14% fat, around 50% starch may weigh 105 grams per cup. While ruler-shaped baked products are even denser because lack of expansion. A product with a similar formula as the cable can weigh around 125 grams per cup. Not only does the type of the product affect the weight per cup, but also other factors such as the formula structure. For freeze-dried morsels, if you include more dry materials in the formula and reduce the meat percentage to around 80% by adding dry vegetable powders or grains, it can increase the weight per cup to around 80 grams. For cable, the density increases with higher protein and higher fat content, while increase with lowering starch content. For example, extruded grain-free cat food with 43% protein and 19% fat may weigh up to 125 grams per cup. Additionally, adjustment in the production process can also significantly affect the weight per cup. So therefore, it is highly recommended that you measure the cup weight of the product you're marketing before a mass production or package is made, so that we can avoid very expensive mistakes. Now I will hand back to Angel. Next slide, please.
And as we transition from household unit to guarantees, remember that the household unit is right up there in that front, very first line, but it's also used in 2 other places. So those measurements that Ding Wang was just talking about and that I had introduced are really important because they are used throughout the nutrition facts. So what's the next thing to look at? We're going to look at guarantees. So how do I set guarantees? Well, you need the basic guarantees now. Again, here's something that used to be basic and we've built on that, but now we have some new twists. So we have protein, we have fat, we now have total carbohydrates, which we'll dive in deeply into in this seminar, And dietary fiber, again, one of the major topics, and moisture. So 3 of the 5 are things that we've always done, and 2 new ones. We're here to tell you about those. Other voluntary guarantees are usually based on what claims there are, and that hasn't really changed. Those regulations haven't changed, and you still need to have guarantees for those. In setting your guarantees, you need to start with laboratory analysis, possibly. Hopefully, if you have finished product, you want to have maybe 3 to 5, 4, somewhere in there of actual analysis for each protein, fat, dietary fiber, and moisture, because that's what you're going to use to set these guarantees. Or if you have, for example, if you go to a co-manufacturer, or if you have a company that's big enough that has good database on their nutrient content of their ingredients, and it has a good predictive program to calculate those nutrients, then you can either use the averages of the analytical analysis, or you can use the results of the predictive equations. What's key here in setting guarantees is that you need to understand variation of your product. So what are the most usual contributors? Well, a lot of us think of AVs, but that's just analytical variation. We also have manufacturing variation, so the people manufacturing understand what the variation might be on any given day in their processes, and ingredient variation. So in setting the guarantees, where you want to have 95 to 99% of your product meet those guarantees. Again, we have minimums and maximums. You don't want to just casually set those. You want to set those understanding the variability. Now, I mentioned analyticals, and I mentioned analytical variation as one of the factors that people are concerned about. And one that's come up in this new format with Nutrition Facts is the whole thing around total carbohydrates. Total carbohydrates is a calculated value. And what I'm going to do next is I'm going to turn it over to Leah and to James, and they're going to dive in about total carbohydrates for you. Next.
Thank you, Angel. So I'm going to kick off this section with an introduction to carbohydrates. So what are carbohydrates? Well, I know you all know, but let's do a little recap. Carbohydrates are one of the 3 main macronutrients along with protein and fat. They are the primary source of energy and supply fiber, which is beneficial for gastrointestinal health. Carbohydrates can be classified into 3 main categories: starches, sugars, and fibers, each playing distinct roles in both nutrition for us and for our pets. Now, the main sources of carbohydrates in companion animal nutrition typically do come from plants, such as grains, legumes, and other fruits and vegetables. And these carbohydrate sources not only provide essential energy, but also contribute vital nutrients and fiber. As Angel said, in this webinar, we will speak extensively about carbohydrates and total dietary fiber and how they are calculated as new maximum guarantees on your pet's labels. Pet food labels. What differentiates the two is that digestible carbohydrates provide a readily available energy source for pets, while dietary fiber contributes to digestive health, but is not a direct energy source. And from here, I will pass on the mic to James. Thank you.
Perfect. Thank you, Leah. That was a great introduction into carbohydrates. I'm just going to take it from here for a couple minutes now and dive into some of the equations. This is going to get a little more dense here, but we're going to talk about how exactly we actually calculate total carbohydrate, at least this portion of the nutrition facts. As like Angel alluded to, this is a relatively new addition to the list of guaranteed nutrients. So for this equation, which you can see up here in front of you, you're essentially going to be subtracting the sum of protein, fat, moisture, and ash from 100. But the key here, and something I'm going to kind of reiterate a few times through this presentation, is that you're going to be using the guaranteed values for protein, fat, moisture, and ash in this equation. So Angel did just talk about guaranteed values a few minutes ago, and I will dive a little bit deeper into how to define those guarantees later in this presentation. So for now, if you take nothing more away from this slide, is just to know that for your total carbohydrate calculation, you're using those predefined guarantees. So you have your guarantees for moisture, protein, and fat right in front of you within your nutrition facts. So that's relatively easy, but what about ash? Now, ash is not, it's not mandatory to include an ash guarantee in nutrition facts, but if you choose to, ash can be voluntarily guaranteed. Now, if you do choose to add this as a voluntary guarantee, ash will be defined in your nutrition facts as a guaranteed maximum, and it will immediately follow moisture within your nutrition facts profile. But whether or not you are voluntarily guaranteeing ash in your nutrition facts, we will need to determine this guaranteed maximum in order to actually complete the total carbohydrate calculation. So to do so, what you're going to need to do is test your product's approximate composition. And as a note, we talked earlier, Angel alluded earlier about recommending multiple times to test to ensure that your data kind of appropriately captures the potential batch-to-batch variability that you may experience. So once we have multiple batch tests of your approximate data, we're then going to determine the average ash content over those batches. And you can see the averages are shown up here right in front of you on this slide. And I think these averages, again, are taken from 4 different batches of this product. And then you're going to take your average, determine your standard deviation, then add 2 standard deviations to your average value. Then by taking that and rounding up, we generate a guaranteed maximum for ash of 4%. And with that 4% maximum, we can then finish our calculation of total carbohydrate. So taking that 100 and minusing the sum of those 4 values, in this case, we get a total carbohydrate content of 52%. And you can advance to the next slide, please. Now, the next question, of course, is how are we actually supposed to use this total carbohydrate calculation? So it's first used to assign a guaranteed maximum for total carbohydrates, being that 52% we determined on the previous slide. But then you're going to use this to calculate the grams of total carbohydrate per cup of your diet, or per whatever your familiar household unit is defined as. So in this case, we've assigned a guaranteed maximum for total carbohydrate of 52%, and this would result in an estimated 41.6 grams of total carbohydrate per cup of our diet. And this is just simply calculated by taking the grams contained within your familiar household unit, which in this case is arbitrarily defined as 80 grams, then multiplying that by your percent guarantee for total carbohydrate. So of course, 52% of 80 grams gives you 41.6 grams of total carbohydrate. And you can advance to that next slide, please. And the final thing I do want to discuss with you here before I do hand the floor back to Leah is going to be the difference between the calculation of total carbohydrate and NFE. So nitrogen-free extract, or NFE, has historically been used kind of interchangeably with carbohydrates. But I think it's important to understand the difference between these two terms, and I think this can be somewhat helped along by understanding the difference in how they're calculated. So we know that when calculating total carbohydrates, we're using the guaranteed values for protein, fat, moisture, and ash. Remembering that it's not mandatory to provide a guarantee for ash, but it can be voluntarily guaranteed. Now, the main point of differentiation when it comes to calculating NFE is that for this equation, which you can all see in front of you, you're subtracting the sum of the average values for protein, fat, moisture, crude fiber, and ash from 100. So, as you can see, there's in fact 2 unique defining features here. First, you're using the average values from your approximate composition data, not the guarantees that you use for the total carbohydrate calculation. And part of the equation for NFE includes crude fiber. And this is a nutrient that was not included in your calculation of total carbohydrates. So this calculation and the ways in which the calculated NFE value is actually intended to be used will be discussed in a bit more detail in the coming slides. So please hold tight if you still have some kind of uncertainty regarding NFE. And with that, we can jump to the next slide and I'll hand it back to Leah.
Thank you, James. Certainly a lot to unpack here, and I'm sure this audience appreciates this step-by-step guidance on calculations. Here we really just want to demonstrate that dietary fiber is the maximum percent of total dietary fiber that the manufacturer or brand guarantees that the diet will contain. Remember that total dietary fiber is considered a component of total carbohydrate because it's chemically classified as a carbohydrate. You will always observe that the guaranteed maximum of total dietary fiber will be lower than the guaranteed maximum of total carbohydrate. Next slide, please. And for this reason, the total dietary fiber guaranteed is indented, as you see here, to reflect that, again, the amount of total carbohydrate will also always be greater than the amount of total dietary fiber. All clear? So to sum up, total dietary fiber is one of the components of total carbohydrate content in foods, including pet foods. Carbohydrates are often divided into digestible and non-digestible forms, and that's really key here. Digestible carbohydrates like sugars and starches provide energy, while non-digestible carbohydrates such as dietary fiber do not get fully digested and instead contribute to gut health by aiding digestion and the production of beneficial fermentation products in the gut. Thank you. On to the next section.
Hi, and I'm Dr. Leslie Hancock, and I'll be co-presenting with Carrie Nichols from, she's a member of PFI through Eurofins. And we're going to talk a little bit more about this new dietary categorization that we're seeing on the facts box called dietary fiber. And thank you very much, Leah and James and Angel, for helping us introduce the new topic. So next slide. Oh, yep, you're on the slide. Thank you very much. So as Leah already said, dietary fiber is a type of carbohydrate, but it's unique because it escapes mammalian digestion. So that's why it's very different. And we can further dissect fiber types on either their physical properties or their biologic properties. So if we were looking at fiber types based on their physical properties, we generally think of them either as insoluble, meaning you add them to water and they don't they'll precipitate. They don't solubilize and dissolve. So an example is if you were to shred up lettuce and put it into a bowl of water, since it's mostly cellulose, which is an insoluble type of fiber, you can see it floating and just sitting whole. Whereas if you've ever made jam or jelly and you warm up water and you add pectin, it stir it up and you're not going to see it. So something similar if you were to take a Benefiber supplement and stir it up in water, the water is going to look clear. Whereas if you took flax hulls and stirred it up in water, you're going to see kind of a muddy consistency at the bottom. So that's just differentiating the fiber types based on their physical properties. Another way to look at fiber is whether or not the gut microbiota can feed off the fiber, and that's fermentation. And that's a really beneficial health property. So while insoluble fiber will tend to be infermentable, soluble fiber tends to be fermentable. Now, there are exceptions to the rule, but as we start thinking about these biologic impacts, you realize that the archaic crude fiber on the label doesn't mean a whole lot to a pet parent, to a veterinarian, to somebody trying to understand the impact of nutrition on the animal. And that's where this evolved from, is how do we make labels more understandable and more relevant? So to take it a step further, we want to also understand the physiologic importance of these different fiber types. And this is why it made sense to add dietary fiber in a functional way in updating the labels. So next slide. All right. So to introduce some of the functionalities of soluble fiber, we think about how it impacts the gut-associated lymphoid tissue, and that sets up a systemic impact to immune health. We also remember that soluble fiber is fundamental in the excretion of certain chemicals and lipid compounds. So think about cholesterol. We think about it in humans. It is important to animals as well. The only way cholesterol gets out of the body is through fiber attachment in the feces. Apologize, I have a barking dog next to me. Another impact is as fiber is fermented by the gut microbiota, it exposes and releases important polyphenols, produces short-chain fatty acids that also have systemic health effects, important trophic factors. It can provide substrates for energy to the brain. We even think about some of the really important, you could consider it the world's original postbiotic that we knew about, which is vitamin K. The mammalian body cannot produce vitamin K, but your microbiota can if they're provided the right type of fiber. And you could classify that as a postbiotic, but if it's not coming in the diet and if the gut microbiota don't have the substrate to make it, it has to get in the body somehow. So these are some real functional needed properties of soluble fiber. So what about insoluble fiber? You might hear it marketed as a filler or something unhelpful. But if you can imagine eating a diet that had no fiber, no insoluble fraction, you'd have nothing for the smooth muscle in the intestines to move, the peristalsis movement of the bolus of food turning into digesta, into feces. It has nothing to move along. And conversely, we could create very obstipated, constipated, and painful conditions if you had a diet totally devoid of fiber. So, that's not very pleasant. But when you start thinking about, boy, we've really not been providing the right information on pet food labels for decades, century, when you think about the functionality of fiber in the diet. So next slide. This is why the decision was made to update, modernize the type of labeling for fiber. So we're moving to what we would consider the AOAC method 991.43. This is the new go-to method. So why? There's innumerable fiber methods. So this method was developed in 1991. That's your 991. Because the prior methods didn't capture those fractions of fermentable soluble fiber types and insoluble. 99143 can report the differences between soluble and insoluble and reports it as a total dietary fiber. So that helps pet food makers make important decisions about the functionality and the behavior of the formula in their diet. The majority of fiber from soluble fractions may lead to why it's important to differentiate the two is, as a formulator, if you see a disproportionate amount of soluble versus insoluble, or an overabundance of insoluble to soluble, you could have some undesirable fecal score events or behavioral components. So that's why the more recent methods, which can become very descriptive of ultra low molecular weight resistant starches and large volumes, those aren't, they would be impactful to the animal, but from a formulator standpoint, it's going to be a very small fraction. So the utility of having those very expensive, very microfiber type reports were not necessary nor practical. And this is why the decision was made that 99143 was representative of a functional fiber on a label. So I'm going to hand it over to Carrie, and she's going to give you a little more information about the methodology.
Yeah, so as Leslie mentioned, with these different types of fibers, we need to consider different methodologies for measuring said fibers. So with this particular method, that is the recommended method 991.43, it does measure high molecular weight soluble dietary fibers. So these are going to be fibers that will precipitate in ethanol in the method procedure. This method also measures the insoluble dietary fibers. However, it does not measure low molecular weight soluble dietary fibers. So these are going to be your oligosaccharides, your inulin, that type of an ingredient that's present. And so these particular low molecular weight soluble dietary fibers are soluble when ethanol is introduced and not captured with this specific method. And as Leslie mentioned, when this method was selected, obviously there are instances maybe where some of these ingredients are included in a diet, but oftentimes they're not included at quantities large enough to make it relevant to measure those low molecular weight soluble dietary fibers. As at large quantities, they could have negative physiological implications. But if you have ingredients or you do have a diet where it makes sense to measure those low molecular weight dietary fibers, there are alternate methods available in the marketplace. So those methods are HPLC methods, so your high performance liquid chromatography. And there are a few different methods that can accomplish that. But right now, the recommended method to measure total dietary fiber is AOAC 991.43 and accomplishes the majority of what needs to be accomplished for our labeling purposes in pet food. Leslie, back to you.
Great, thank you so much, Carrie. So the next aspect is, how are we going to set guarantees? So the regulations haven't changed in how fibers to be reported as a maximum. But because this is a new category of fiber, your label does need to be compliant with the PF5 3A4, either as analyzed finished product would behave. So there's a fine line between a misleading maximum and a worst case scenario. So we fall back to the finished product analysis, your rolling average of 4 or 5, your standard deviation. The reason why we look at 2 standard deviation is that ensures that you have greater than a 95% confidence interval that you're going to be below that maximum. So that's something that we just need to be so clear about, is how you're getting that amount, whether it's through analyzed finished product or a robust ingredient nutrient database. You take your maximum, your standard deviation times 2 and add that to the top. And that should give you that good confidence that you will be below that with regular manufacturing. Now, when I say that robust ingredient nutrient database, when Leah mentioned we typically think of where carbohydrates come from plant material, fiber, we might fool ourselves into thinking it's only coming from plant material. But in a perfect world, you will have a robust ingredient nutrient database that has every ingredient that you're using with accurate repeated measures of analyzed TDF based on the 991.43. Don't make assumptions that some of your ingredients don't have fiber. And this becomes important when you're looking at animal plant material that might contain bone, might contain hair fiber, connective tissue. We often forget that organ, connective tissue, the pluck, viscera have compounds that are going to be picked up and detected as fiber. Even hide can be detected as fiber under these analytical methods. And they behave like that nutritionally. So they escape mammalian digestion. They can have an impact on soluble or insoluble fermentability or propulsive motion. So whether you are choosing to create a robust nutrient ingredient database, or if you are choosing to analyze your finished product, be consistent, collect ample information, and remember to seek the answers that you don't that you don't realize that you may have gaps in. That's really where I wanted to end that. So if you have any questions around product analysis, ingredient analysis, and building ingredient database, we can add that to the beginning and the end. But I hope that provides guidance as to how you can accurately set a maximum guarantee for dietary fiber as a component of your total carbohydrates. And now I'm going to hand it over to the next topic, which is calories.
All right, thanks. So so we're going to dive into the world of calories here a little bit, and primarily how you can and should declare your calories within your nutrition facts. So first and foremost, with PFLM, the foundations of how we do calorie work is the same. So we will continue calculating and expressing through metabolizable energy, utilizing that modified Atwater method. What's also the same is that we still have the option to declare our calorie values either through a calculated value or as a fed value using those AFCO feeding procedures. So what's different is that formally, while we are required to put kcal per kg as well as kcal per household unit within our labels, we are now moving only to declaring calories per familiar household unit. So back to those earlier slides when we were talking about per cup or per ounce or per treat. That is how we'll be declaring our calories. And in addition to that, we will be providing some more information for our consumers about where those calories are coming from. So we will also be adding the declaration of calories from protein, fat, and carbohydrate. So we can go to the next slide. All right, so I'm going to walk through how you would put together your information for a product with calculated calories. So before starting, what do you need to pull together? So for calories, we want to work off average values. I know we've been talking about kind of guaranteed values and average values. For these calculations, we want to use those average values from those proximate analyses, and these are on an as-fed basis. So you'll see the list here of the things that you need to pull are crude protein, crude fat, crude fiber, moisture, and ash. And it's important to note here that we're not talking about dietary fiber. We are talking about crude fiber. And I know this can be a point of confusion because we're guaranteeing dietary fiber, but to do the calculations needed for calorie declaration, we need to make sure we're pulling our average value for crude fiber. And to that point, you can see why it would not be easily attainable to pull calorie information just from your guarantees. So we will move on to the next slide, please. All right, so we have average values here, and we're gonna start walking through our calculations to get our calorie information. So we have our table here of average values. And the first step that we're going to do is do our nitrogen-free extract. James did a really good job of setting this up and expressing the differences between total carbohydrates and then NFE. So here you'll see, again, we're using our average values. We're going to use those and put them into that equation that we've set up here for you guys and get that value. Now it's important to do that step first because you do need that NFE value to calculate your metabolizable energy of your product. So to do that, we want to use, again, that modified Atwater formula. We've put it here. So we'll be pulling our information from our crude protein, our crude fat, and then that NFE value that we just calculated. So, excuse me. So we do the equation here, and then we've pulled together our kcal per kg information. So you're probably pausing and saying, well, why are we doing kcal per kg when we just said we don't have to declare that anymore? So we don't, but we still have to get that information together because then we're going to input it into some other equations to put into our nutrition facts. So next slide. Okay, so now we have our average values. We have our modified Atwater value or our metabolizable energy of the product, and then we have our NFE value as well. So the next thing we need to do is start filling out our nutrition facts. So you'll see we have our simplified nutrition facts box over here on the left. So the first thing we need to look at is the calories per household unit. We've established earlier that we have a cup of product here and it holds 80 grams of food. And so what we're going to do is take our metabolizable energy. You can see here we've converted it from kcal to kg to kcal per gram, just to kind of apples to apples make an easier math equation here. So we're going to take that metabolizable energy and multiply it by the grams within our household unit. Again, we're using a cup here. So that gives us our 295 calories per cup. So we input that here and you'll see that little dagger symbol. And so to remind everybody, that dagger symbol indicates that this is a calculated value. So with PFLM, anytime we're expressing something as a calculated value, we want to add that dagger symbol. And it's just with every other asterisk type symbol you put onto your labels. You need to have a disclaimer or an explanation of what that means. So you'll see at the bottom there, we have our little symbol and expressing that this is a calculated value. Now, when you put this into your larger, expanded nutrition facts box or nutrition facts information, that little symbol will be, at the end after following your guarantees. So we have our calories per household unit. And now we need to do our calories from protein, fat, and carbohydrate. And to do that, we want to go back up to our average values, and we're going to multiply those by our unit grams. And then we're going to take those and multiply them by their specific modified Atwater factor. So we'll go through protein, we'll go through fat, and then carbs. And you'll see we're using that NFE value. That's where that one comes in here. We do the equations that are set there on the slide for you guys, and we take those and we input them into our nutrition facts. And important here is that for the nutrition facts box specifically, that information comes right after the calories and then it's indented. So similar to the total carbohydrate in our dietary fiber is an indentation showing that those two are connected so the consumer can put those two and two together. And now I'll hand it over to Angel so she can talk about fed calories a little bit.
Yeah, so as Lauren had said, we've always had both the ability to do, and this is not changed, to have calories by a calculation. And that's really what the vast majority of products are done with, or their calories are calculated. But there's also a testing protocols, so feeding protocols that are in the AFCO official publication, where you can do the feeding protocol and determine the calories that way. But that leads to slight changes when you're talking about nutrition facts and how those are displayed in the nutrition facts. So what you see here is you see, again, the header nutrition facts, what the household unit is, and then calories per cup. So the unit is cup, but now you've inserted a parentheses that says fed. So this fed refers to the method of determination of calories. It is not as fed, because as fed is about moisture. So here we're talking about fed for the calories and the method of determination. And you don't see a dagger symbol in that first line, but what you see in the from line, you have calories from protein, calories from fat, calories from carbohydrate, and those numbers are calculated. So there is a dagger symbol that will lead to the footnote, as you'll see in subsequent slides, that will lead to the footnote that says calculated value. Okay, let's take some looks at some of how these look when they're translated into nutrition facts. So next slide. So what you'll see on the left is what we determine as the box, and what you see on the right are small packaging and very small packaging. Remember at the outset, I said you needed to know before you started what your total printable area was. So the three categories are greater than 40 square inches of total printable area, 12 to 40 total square inches of printable area, and then less than 12. So these very small packages, which in most cases are intended as single feedings, have some abbreviated nutrition facts. But if we look on the left again, you'll see and highlighted in the box, there's the calories per cup, and that's a calculated value. So you see the dagger, and then you see from protein, the amount of calories from protein, fat, and carbohydrate. And down below it, you'll see there's the footnote that captures calculated value. Now that changes slightly when we go to the small packaging. We have calories, and because it's a small packaging, you don't have to repeat what the line is above it, which says per 1 cup. So these are calories. It's inferred that it's per 1 cup. You've got the dagger so that it's calculated. And then you still have the full from line of the numbers of calories from each of the protein, fat, or instead of having to write out carbohydrate, you can abbreviate that as carbs. And again, you have the dagger symbol down to calculated value. For a very small package, again, these are the very tiny ones, you have calories, and that's abbreviated now on these small packages as cal. And then you have, which may seem a little counterintuitive, but because we need to tell people how they were determined, you have in parentheses calculated. So you don't have a dagger, you have CACLC, so calc, and then the number of calories. And you, again, don't have the dagger, so you don't have that additional line in the nutrition facts. So let's look at what the example is for fed. Next slide, please. So this is when these examples are when you have fed. So on the far left side, you have the box, which is for greater than 40 square inches. You have calories per cup, again, fed in the parentheses, no dagger on that first line. but the same from line, protein, fat, carbohydrate, and the dagger there leading down to the footnote, because it's indicating that those are calculated numbers. On the right side, you have small packaging, calories again, fed, the number of calories per that household unit. Remember, we said we were going to use household unit in various places, and this is continuing the various places it's used in calories. And then the from line with a dagger leading to the footnote. Very small packaging, it would say cal, which is the abbreviation for calories, and then the parentheses with fed and the value for that. So these are the different ways that you would express the calories on pet food, depending on whether it's calculated, the vast majority of them are, or fed. And I believe that finishes our section, and we move on to the next section of the example, which is very exciting.
Perfect. Thank you, Lauren and Angel. That was great. Really nice lead up to what I'll talk about for these last few slides. It'll just be me presenting, but I just want to give a shout out to Lars for helping with the development of these slides. So I'm back, and this time we're going to be really walking through all of the calculations necessary to build the entire nutrition facts profile kind of from scratch. Many, or I think all of these points have already been discussed throughout the presentation. So this is really just meant to be a refresher to try and bring everything together. I know reiteration is key for me when it comes to remembering how to do something. So I'm hoping it's going to help you guys here today as well. So our first step, we're going to start out super simple. We're just going to define our familiar household unit. So today, for simplicity's sake, I'm going to be using one standard 8-ounce cup. But as it's been mentioned earlier on, depending on your product, this unit could be defined as one can, one treat, one piece, one pouch, among a plethora of other options. All that matters is that you define your familiar household unit, and that definition aligns with how your feeding guidelines are developed. And also, just for, again, make note of this, I'm just going to be arbitrarily defining that my cup here contains 80 grams of our diet. And you'll see how that unit of mass comes into play a few more times throughout the next couple slides here. So I'll just jump to the next slide, please. So the next step, of course, is to calculate our guarantees. And while there are a few different ways this can be done, today I'm really just going to focus on calculating those guarantees using that proximate composition data, of course, from repeated analysis of your diet or your product of interest. However, before you dive in and start to take your data set and immediately calculate your guarantees from it, I think it's really important to kind of keep some aspects under consideration. So for instance, does your data set make sense for your particular product, right? Are there any unexpected outliers that may be falsely affecting some of the calculated averages that you're going to determine, right? Or does your data set capture the amount of variability that you would expect? Whether your answer to that question is yes or no, I think it's important to also consider the different factors that may contribute to your variability that you could experience within your finished product, right? Obviously, we have a lot of variability when it comes to ingredients or raw materials. You can also have batch to batch variability. You can have mixer variability. And then, of course, you can experience laboratory or analytic variability as well. These questions about potential sources of variability should also make you think about things like, why was it prudent to have multiple batches tested rather than just relying on a single data point? And maybe it comes to when and why you should account for seasonal variability in your finished goods or your raw materials, right? Maybe you have a diet that's got a really high fish inclusion. Should you be considering the fact that for many species of fish, fat levels within those fish will change with season and water temperature and diet availability, right? Only after considering all of these different factors and really determining that your data set is the best or most accurate representation of your product of interest, should you then proceed with calculating your guarantees from such a data set. And that's what we'll do on this next slide. So we're comfortable with our data set. I'll just hop back one slide, actually, if you don't mind. Thank you so much. We're comfortable with our data sets. The next question, of course, is how are we actually calculating these guarantees? So in a nutshell, you're going to be determining your average value for each nutrient over these 4 batches. You're then going to calculate a standard deviation for each of those nutrients. And finally, take your average values plus or minus 2 standard deviations. And now for reference, when you're assigning 2 standard deviations for nutrients that are presented as a minimum, you're going to be subtracting that 2 standard deviation from your average. And vice versa for nutrients that are being presented as maximums. In those cases, you'll be adding 2 standard deviations to your average. And then by rounding down or up respectively, you have values to assign for your nutrient guarantees. So by adding or subtracting 2 standard deviations from your average, you will, in theory, as long as your variation is normally distributed, be ensuring that 95% of the time your product will meet the guarantees you've defined. But I think that even this process raises some questions that you should also be carefully considering, right? Is 2 standard deviations sufficient to account for your expected variability, right? This accounts for a 95% plus confidence interval, but are you worried about that 5%, right? Should you be taking 3 standard deviations rather than 2? Once again, this is a situation where you need to really carefully consider how confident you are in your data set and how much variability you would expect to see maybe throughout the batches produced or throughout the year that you're producing this product. These are all key factors when you kind of consider your own internal risk assessment as it comes to applying buffers around these average or typical values. As well, you can also be in situations where maybe you do not or cannot have multiple batches of your product tested to gather the data that you see here today. So in situations like that, what other options do you have when it comes to calculating guarantees? This was mentioned earlier on, but maybe you have enough or sufficient data on all of your raw materials. And in that case, you can use simplistic software like Microsoft Excel or even more sophisticated softwares like Concept 5 to formulate your diet and thereby producing theoretical proximate data. But then you also need to have a very thorough understanding of your raw materials and of all the expected or potential variability, as you have to build in your own buffers when extrapolating from raw material data to finished good guarantees. So just a bit of an indication as to what else can be done. But again, we're really going to be focusing on how to develop all this based off of serial batch testing of our products. So jump to the next slide, please. So back to our calculations, the next step, of course, is to calculate our total carbohydrate. And this is a calculation I've already gone through once with you guys, so I'm hoping it's going to be fresh on the brain. If you remember back a few slides, you'll hopefully recall that to calculate total carbohydrate, we take 100 and subtract the sum of protein, fat, moisture, and ash. But the key here is that the values you're using for this calculation are the guarantees for each of those nutrients. We determine guarantees for protein, fat, and moisture on that last slide. And of course, you can see them right there in your nutrition facts profile. But remember, it's not mandatory to include an ash guarantee in the nutrition facts. So we can't always just be pulling that right from that facts profile. We have to calculate it first. So we're going to take the average ash content from our 4 batches. We're going to add 2 standard deviations to that average because remembering back, if we were to guarantee ash, it would be a maximum guarantee. And then finally, we're going to round that value up to generate our guaranteed maximum for ash of 4%. And with that, we can finish our calculation of total carbohydrate. And one more thing I just want to make note of here, again, this was spoken on earlier on, but I'd like to reiterate, is the fact that you can see dietary fiber being slightly indented underneath total carbohydrate. This is again to ensure that the consumer understands that that total dietary fiber maximum is a portion of your total carbohydrate maximum. Again, this is something Leah mentioned earlier on in the presentation, but I think it's a tidbit that's kind of important enough to reiterate here. So we'll jump to the next slide, please. So next, we want to determine our per cup amounts of each of our guaranteed values. And we do this by taking the guaranteed percentage and multiplying it by the number of grams in our familiar household unit. So for instance, we can see here that our moisture maximum is defined at 10%, and our cup or our familiar household unit here contains 80 grams of product. So 10% of 80 grams is 8 grams, and that's how we determine the per cup basis for moisture. And you'd apply that same simple equation across the rest of your nutrients. Next slide, please. And finally, the last part of this puzzle is all about calories. We just got a really great kind of description and walkthrough of these calorie calculations. So hopefully these are also fresh in your mind. But you can see that while we need to determine the caloric content of our familiar household unit, here being calories per cup, we then need to take that to estimate those calories as they're coming from their 3 primary macronutrients, being protein, fat, and carbohydrates. So the first step, or I guess you could say sub-step here, would be to calculate NFE. So as you hopefully remember from earlier on, NFE is calculated as 100 minus the sum of crude protein, crude fat, moisture, crude fiber, and ash. More specifically, remembering that these are the average analyzed values for these nutrients, again, from those 4 batches of your diet that we had tested. And just a note, this is the same data you guys already saw earlier. I just really shortened it a little bit to cut out some of the clutter. I also want to reiterate that for these calculations, you are not going to be needing that TDF data. You're only going to be needing the crude fiber data. That's a component of the NFE calculation. So we've completed the calculation. We get an estimated NFE content of 45.15%. And we'll jump to the next slide to see how we use that. So we've calculated our NFE. The next step is to calculate our calories or metabolizable energy. And in this case, the first step is to determine on a kcal per household unit basis. So this has been talked about a little bit earlier on, but metabolizable energy is always determined on an as-fed basis, and it's calculated using what I'm going to refer to as the modified Atwater factors. So these factors really define an estimated metabolizable caloric content per gram for each of these 3 common macronutrients, being protein, fat, and carbohydrates. Grams of protein and carbohydrate are multiplied by 3.5 kcals, while grams of fat are multiplied by 8.5 kcals. You're then taking those calculated values together, multiplying the sum by 10, and we get an estimated 3,688 kcals per kg. So again, we used to use kcals per kg right on the bag, not necessarily going to be doing that moving forward, but we still will need that kcal per kg outcome to determine our kcals per our familiar household unit. So we're going to convert from kcals per kg to kcals per cup. We know that our cup contains 80 grams of diet, so you do a little bit of magic and you end up with a predefined household unit containing 295 kcals per cup. So it should be noted, though, that again, while that caloric content is so often calculated using the method that I just described above, it can also be determined using feeding trial testing procedures determined by AFCO. And in the case that metabolizable energy was determined using these AFCO-defined testing procedures, that dagger symbol that indicates a calculated value will now be taken off of that calories per cup, because again, that's no longer a calculated value that's being determined in life with feeding trials. And the words as fed will instead directly follow that per cup. You'll then shift that dagger symbol that indicates a calculated value after the number of calories from carbohydrates, because again, we need to define that although the total calories are determined using feeding trials, that our calories from each nutrient are still being calculated. Next slide, please. And finally, you made it all the way through. Our very last sub-step here is to calculate the calories from each nutrient. And to do this, we're going to take those average values for protein and fat from our approximate data, as well as our calculated NFE value. We're then going to multiply those by the number of grams in the familiar household unit, and then, of course, account for our modified Atwater factors for each of those macronutrients. So, for instance, in the case of protein here, we're going to take the average crude protein value of 24.8%, multiply that by 80 grams, which is within our household unit, and then multiply that by the Atwater factor for protein being 3.5 kcals per gram. And we get an estimated 69.4 kcals for protein, which we are rounding to 69 and including right there in the nutrition facts profile. And then the same will go for fat and carbohydrate, but of course remembering that those 2 nutrients have different modified Atwater factors, being again 8.5 kcals per gram for fat and 3.5 kcals per gram for carbohydrates. And with that, you've successfully done all of the calculations necessary to build a complete nutrition facts profile for your product. You should be really proud of yourself. That was a lot of steps and a lot of math. But we also hope that this kind of brought together everything from this presentation, as this has taken us to the end today. But if anybody does have any questions, we'd be more than happy to try and answer them for you. And that's the end. That's all I got.
Just a
All right, thank
reminder,
you.
just a
Carolyn,
reminder
we have
that,
2 questions.
okay, let's go ahead and talk, just get this in-person meeting out first. Just a reminder that labeling laboratory, obviously that this training differs from what regulator training is. Regular training would never go through all of these calculations, would never go through all of this discussion. So we are going to have a labeling laboratory in-person, industry to industry training. You can bring a team as long as you bring a bag, box, can, or label with you. It'll be February 18th and 19th, 2025 in Dallas, Texas, and registration will open next month. So now we'll turn it over for questions.
All right, thank you, Carolyn. So we just have two questions. I forget which slide it was. It might be Leslie or Leah's slide that was mentioning low molecular weight soluble dietary fiber. So one of the questions is around, could a list be shared of the most common feed ingredients that meet this definition?
That was my slide. And yes, I mean, there are likely resources already available for that. So Carolyn, I can work with you to get something put together there.
We can add a list of those into the slide deck when we put it up on the website.
All right, thank you. And then the second question is around calculation of dietary fiber. So just to confirm, total carbohydrate can be calculated based off the other guarantees. However, to define dietary fiber, we must be able to physically test it for dietary fiber levels, meaning that there's no consistent way to just calculate dietary fiber. And the answer to that is yes, it must be calculated, or it must be analyzed. It cannot be just calculated. And with that, there are no other questions in the chat. Carolyn, I'll turn it back over to you.
Okay, if there's no other questions, this concludes the fourth webinar series. The fifth one will be in November. You can go ahead and register on the website now. And we'll have the final webinar. And then we also will have on ingredients and ingredient handling. And then we will have the in-person webinar, in-person meeting in February. Thank you, everyone.
Great, thanks for attending.
Thank you, everybody.